Hey everybody, welcome back. At this time, we will have an astonished class about balance and no balance force. Do you want to know more? Let's hit it right running because it's Miller time. We, the first concept that we need to grasp or to understand is what is a balance force about? What is the concept about? So let's figure it out by defining this in this way. Balance force means that at forces, assuming forces, and the outcome is zero. Then you say something is static because friction is equal or is the same amount of motion, then it's equal zero. Motion equal friction, zero. Weight, here I have misspelled it, apologies. Weight is equal normal. That's why it's static, right? Then let's define this like the way that we have to assume and to know what is the outcome. If the outcome is zero, it's a balance force. But if the outcome is different than zero, or that it should be positive, right? Should be greater than zero, right? Then greater than zero, the meaning that is in motion, right? Because if equal zero, it's static on the forces assuming zero. So let's figure it out, or let's have a better understanding on this by having this. Here we are saying movement on X and movement on Y, right? X, Y. Okay? In this part, in X, it's a static. In Y, it's a static. If I start jumping, in Y is different zero, right? Because I am jumping. But in X is zero. And when I'm doing this, I am moving, right? On X. X is different zero. But Y is zero. What about if I do this? I change the position by jumping. When I jump in, I am changing X and changing weight at the same time. I'm describing a parabolic, right? Then when I'm doing this, I'm trying to explain you that the balance force, the meaning of behind this is that the sum of the forces is zero. Balance force, zero. Balance force, zero forces. That's why I'm here describing a movement, right? So let's think of this. In X, on X, will be studied, right? Until this electric motor will produce the energy, right? It will be static. No, it will keep advancing like in this way. What about if I disconnect this? It will be static, right? What about if I, instead of move this on X, I will be start launching. 5, 4, 3, 2, Houston. Right? On Y it's moving. On X is static. What about if we do this much better? We just jump this like a rocket. We create a rocket. Houston, we got a prime here. X and Y, right? All just on X. Just on Y. But, okay? The balance forces. When it started moving, the meaning behind this is that the force is different zero, right? Motion, different zero. Motion, different zero. Different than zero, right? Different than zero. Okay? Here we are explaining this, apologies, here. And movement on X. Then the weight and the normal is the same on X, just on X. It should be static, okay? But it has an electric motor, just like a real car. The motion, and there's an opposite force to motion, that is friction. And even there are two kinds of friction: kinematic friction and static friction. But we are just nowadays static friction, right? So now we have the friction. Now the sum of friction and motion is 0, and the sum of weight and normal is 0 as well. That's why I'm saying x motion minus of subtracted with the friction is equal 0 Newton. Weight normal minus weight is equal 0 Newton. If the result of the outcome is 0 Newton, the meaning behind this is that it's static. But if my equation is providing me an outcome that is this symbol, different than motion and minus friction is different than 0, right? Different than 0. Now, this is on x because it's moving. And on weight, the normal minus weight is 0. Equals 0, different 0. Equals 0, static on weight. Different than 0 on x is moving. It's moving, right? Then that's the science behind that scientific fact. Okay, if you have this, if you ungrasp this, you are able to figure it out by samples, right? Like different. You have to write this sample down, know how you have to use it. It is called a logic connector. I'm connecting an idea with an outcome, with a connector, right? Here, we are staying the moving on way, right? Zzz. Then if I jump and I start falling, like this guy, this guy is falling. This guy, I don't know what this guy is doing, but this guy is falling, right? It's falling. Let's imagine that this guy is falling and it's not moving, and it's not moving on X, right? It just in a straightforward line, right? Now the movement, it's equal weight equal friction. It's a balance force, right? When I have the terminal velocity, that is a concept that we need to understand, is when the forces are the same. Weight equal air friction. Then it's like when you're planning, you are not falling, you're not doing nothing. You're balanced, right? That's, I guess I have not done this, and I guess that I'm not going to do this. But if you jump from an aircraft, I will not do it. But but if you start falling, there's a moment where the forces are balanced, right? And you're planning. You're not falling. You're not doing nothing. You're stable, right? You're steady. So, but if the weight is major than, then we need to add another concept here. That is this another symbol that perhaps you're not grasping yet or you're not understanding. Is this greater than? Greater than and less than. Okay? So we have to understand that concept. If I need to conclude, there are 3 main states, right? First one, when nothing is moving, and when nothing is moving, the science behind this is that the force, the sum or the result, the outcome of all the forces is 0. On X, friction and motion, it's equal. And in weight and normal, it's equal. That's why the object is static, right? Just like this. No motion on wakes, no motion on weight. It's static. But if it would be weighter than the force that I'm doing this, than the normal, it is not falling. But if I connect the motor and right, it will start moving, right? Because the applied force is greater than friction. It's a pretty easy concept to understand, right? It's not a rocket science, right? So equal friction is when nothing is doing nothing, right? Somebody is suspended there. It's no falling, it's not doing nothing. It's the ideal state for somebody that is skydiving, right? I'm not going to do it. It's never in my life. Perhaps I have suffered a heart attack. So now you already know here the air friction and the weight. Recall weight and x. Weight is equal. Weight minus air friction. Weight is different zero and it's positive, right? It's different zero, except in this state, terminal velocity, weight is equal friction. It's not doing nothing. It's equal zero. Equal zero. Different than zero. It's pretty easy to understand. If you have got some questions, please don't hesitate to ask them on the comments below. And please feel free to contact me. Do you want to know more? See you in the next class. It's Mele time, you know.